Okay, hello. My name is Peerapat Keawsaituam. I'm a third year college in King Mongkut University, North Bangkok. Today, I would like to present you about the digital key lock for 4 digit passwords. Okay, the first topic is pre-processing unit, and here is the equation S bar O with the S0, S1, S2, S3, S4, S5, S6, S7, S8, S9 with the bar. And here is the circuit of the pre-processing unit. That's made the S bar O. And the next topic, I would like to present about the circuits of the digital key lock of my 4-digit student number 0181. Okay, in the first stage, the A state, wait for press 0 or press 1 to 9 or not press. It will loop in the same state A. But if press 0, it will go to the next state, state B. In this state, if we not press 0, it's gonna looping in the state B. But if we press 0, it will go to the next state, state C. And it is if we don't press 0, okay, it's gonna go to state C. Sorry. In the state 3, if we not press anything, it will stay in state C. And if we press 0 or 2, 3, 4, 5, 6, 7, 8, 9, it's gonna return to state A. But if we press 1, it's gonna go to state D. In state D, if we not press 1, it's gonna stay in state D. But if we press 1, it's gonna go to but if we don't press 1 and cancel the pressing, it's gonna go to state E. In the state E, if we don't press anything, it will stay in state E. And if we press 0, 1, 2, 3, 4, 5, 6, 7, it's gonna return to state A. Or press 9, it's gonna return to state A. But if we press X, it's gonna go to state F. In the state F, if we continue press X, it's gonna stay in state F. But if we cancel pressing X, it's gonna go to not press state G. In state G, if we don't press anything, it's gonna stay in state G. But if we press once, it's gonna go to state H. In the state H, we wait for cancel press 1, and if we cancel press 1 or don't press anything, it will go to state I with the open of the door. But if we don't press anything, it's gonna stay to state I and open the door. But if we press 0 to 9, it's gonna return to state A. Okay, finishing the straight diagram. Okay, in the state table, I'm just gonna present you the two example in these two states. Okay, first in state A, we wait for press 0 and then we press 0, it's gonna go to state B, but if we don't press, we press 1, press A, or press another, or don't press, it's gonna stay in state A, and output gonna be 0. In the next state B, we wait for cancel pressing 0, it's got, it's now stay in state B, don't press anything. But if we press, but if we don't press anything and cancel press 0, it will go to state C, and output gonna be 0. Okay, I'm gonna give you these two examples because in the state table is similar to state diagram. And next, okay, and the next topic is state table assignments. In the state table assignment is I would like to say is as the same as the previous state table, but it is changed from the a letter to gray code. Yes, and it's different. But I'm checking the flip-flop in this. I'm in this state for checking the flip-flop D1, D2, D3. Okay, next is the means term. I make for the data from the state to make the mean term equation to use for flip-flop D1, D2, D3, D4. Okay, I'm gonna show the equation first from the flip-flop D4. Okay, if you take a look, I made the flip-flop D4 for the yellow color, and you're gonna see it have in this state, and we like it in the equation like this. It have in the state D4 we have A S0, B S0, B S bar O, C S bar O, E S X, F S X, F S bar O, G S bar O. Okay, and we use the mean term equation to and the flip-flop to this equation, and you can see we're gonna use this d bar d2 d3 sx for the writing the circuit, and in d3 we have bs bar o, cs1, cs bar o, ds bar o, ds bar o, esx, es bar o, fsx, and this is the finished equation. And for the D2 we have ds bar o, esx, es bar o, fsx, fs bar o, gs1. If the finished equation, d bar d3, d1 bar d3, d4 bar s bar o plus d1 bar d2 d3 sx plus d1 bar d2 d3 d2 d4 s bar o plus d1 bar d2 d3 bar s1 plus d2 d3 bar d4 bar s bar o. And the next flip-flop d1 we have h s bar o plus I s bar o, and this is the finished equation, d2 d3 bar d4 bar s bar o, and the output is slash that we use for the circuit equal I s bar o, d1 d2 d3 bar d4 bar s bar o. Okay, for the next is design middle block using D flip-flop, and here is the 4 flip-flop that we use. Okay, start from the D4 preset and set D3, D2, and D1 with the clock for doing the clocking. Okay. Okay, and the next topic is design test vector table. Okay, I'm gonna start for the okay, first we have clock set 0 to 9 and clock 0 to 14. Okay, I'm gonna start from a state 0, clock 0, state A, and then we run, and then we wait for the, and then we wait for the pressing 0, state A, in the state A, and then we pressing 0, let's go to state B. In state B, we wait for the release 0, and if we don't release 0, it's gonna stay in state B. And the next step, if we release 0, it's gonna go to state C. In state C, we wait for pressing 1, and if we pressing once, it's gonna go to state D, but if we not pressing 1, it's gonna stay in state C. Okay, in state D, we wait for release 1. If we not release 1, it's gonna stay in state D, but if we release 1, it's gonna go to state E. In state E, we wait for the pressing X, but if we not pressing X, it's pressing anything, it's gonna stay in state E. And if we not, and if we press 0, 1, 2, 7, or 9, it's gonna return to state A. This, okay. But if we press X from state E, we're gonna go to state F. In state F, if we wait for pressing X, but if we not release, we wait for release X, but if we not release X, it's gonna stay in state F. But if we release X and not spread anything, it's gonna go to state G. In state G, if we don't press anything, it's gonna stay in state G. But if we press one, forgot. In state, I forgot. In the state G, if we press 0 or 2 to 9, it's gonna return to state A. I'm sorry, I forgot in the state diagram too, but I'm gonna explaining here. Okay, next. In state H, in state G, if we press 1, it's gonna go to state H. In state H, we wait for the release 1, but if we don't release 1, but if we, oh sorry, my bad. But if we release 1 or don't press anything, if we go to state I with the open state of the door, in this state, if we don't press anything, the door gonna still open and open. But if we press 0 to 9, it's gonna return to state A. Okay, this is the design test vector table. and in the set is the output. Okay, we gonna go to the next topic. The next topic is the circuit that I have simulated in the quarters program for showing you. Okay, in this topic we have this is the pre-processing unit, and and this is a right block, and it's the left block, and we have a middle block in here. Three step, three think for the unit. Okay, and the next topic, Quartus simulation result from using my equation and test vector table. And here is the result from testing. First, clock 0 to clock 14. Okay,